So let's look at the topic extensively well for GCSE math. Iterative method is one of those methods that people consider to be difficult, or they can see it like a boring aspect of mathematics. However, it is very, very easy and simple. Just that you need to continue repeating your calculations with different values in order for you to arrive at your answer. So in this video, I'm going to explain the ones that you can see in the class and the ones that you can see both in the class and in exam. Because one thing is that mathematics is about pattern. And for you to understand it, you must be ready to shift your perspective. What do I mean? What your teacher will show you in the class is just one pattern out of many of patterns in which questions can come under this topic. So you don't want to close your mind into what the teacher said alone, because there's no enough time for the teacher to explore every other kind of pattern under this particular topic. So I'm going to be considering different patterns in which you can be asked question as far as GCSE is concerned under this particular topic. But we'll start from the one that you are familiar with. So let's look into that. So this is the one that you are most familiar with, and that's why I'm starting with this. Usually, your teacher will give you questions like this in the class as example or assignment. Show that when f of x equals 0, the equation f of x equal x cubed plus x minus 3 can be rearranged to give x equal the cube root of 3 minus x. Then they'll go to the second part of the question, which is the B part. Use the iterative formula x sub n plus 1 equal cube root of 3 minus x sub n with x not equal 1 to find the root of f of x correct to 2 decimal places. Now, before we go on, what I want you to understand whenever you are given this kind of a question is that this is a cubic equation. Normally, you are supposed to have 3 different answers or 3 the same answers for this particular equation because it is a cubic equation. If it is quadratic, you are expected to have 2 answers, and if it is linear, you are expected to have 1 answer. However, they are asking you to look for just a single value for this particular equation that will reduce to this. Even whenever you take the cube root of any number, you are meant to have 3 results. It's just like you have square roots that your result is either going to be plus or minus that particular value that you have. The same thing goes to when you take the cube root of a number. So whenever you have cube, you are expected to have 3 values. But why are they asking us to look for just one value here? Which is one thing that you can be confused about, because if you see another question that is now asking you to look for 3 answers, then that might be difficult, which we are still going to consider. Reason why you are asked to look for just one answer here is because the remaining 2 answers might be imaginary numbers, that is, they are complex number. And at this level, you are not dealing with complex number. That is the reason why you are asked to look for just a single value for this cubic equation. I hope you understand this. Good. So let's deal with the first one. Now, this first question, which is question A, show that when f of x equals 0, the equation f of x equal x cubed plus x minus 3 can be rearranged to give x equal the cube root of 3 minus x. They can decide to change this question to x. They can say you should show that x equal 3 minus x cubed. What am I trying to say is that it's not necessarily that they pick the one with the highest power, but mostly they always pick the one with highest power. So it's just for them to make any of these x the subject of the formula. For example, with the question that we have, it is this x that they make the subject of the formula. And with this one, it is this x that they make the subject of the formula. So whenever they ask you to show or to rearrange to this particular form, what you should look out for is that which of the x are they making the subject. Do you get that now? So let's start with the question. Let's start with the A part of the question. So we have f of x to equal x cubed plus x minus 3, right? You are told that f of x is equal to 0. What does that mean? That means x cubed plus x minus 3 equal 0. So we want to make x cubed the subject of the formula. That is what we need to do because that is what they did to arrive here. So what do? We had 3 to both sides so that this 3 can cancel here, or better still, you can just transfer 3 to the other side so it becomes positive. Then you have x cubed plus x equal 3. So the next thing now, to make x cubed to stand on its own, we have to take this x to the other side as well. So we have x cubed to equal 3 minus x. Now we have x cubed equal 3 minus x, right? But we want x to stand on its own. This is cube. For us to remove this cube, we cube root both sides of the equation. Therefore, we have that x equal the cube root of 3 minus x. And we have been able to rearrange this given equation to look exactly like this. Do you get this now? Now, you need to be careful whenever you are writing this, because this is an exam. If you write this as x equal 3 roots this, you are writing something else. This is 3 multiplied by the square root of 3 minus x. It's not the same thing as this. So you need to make sure that your 3 is inside this shape. Am I making sense? With that, you are done with the A part of the question. So now let's look at the B part of the question. For the B part of this question, we're asked to use the iterative formula x sub n plus 1 equal the cube root of 3 minus xn with x not equal to 1. So what do we want to do here? We want to start generating sequence of results until we get to the actual result. Am I making sense? So that you can get what we want to do correctly, which is what we refer to as iteration. So is this, if you look at the graph of x cubed plus x squared minus 3 equals 0, you likely have something like this, like something like a wave like this. You see this point here where this line touch this place, that's the value of x. Am I making sense now? So if this is the value of x, what we want to do now, they ask us to start with x not equal to 1. So if we start with 1, maybe the result we are going to be getting is going to be somewhere here. When we do it again, the result will be somewhere here. When we do it again, the result will be somewhere here. So we'll continue doing it until we move and get to this place. So when we get to this place, that is where we are going to stop, which is going to be our result. Do you get that now? So when I say iteration, is you moving gradually, closing or closer to the question, to the answers. Do you get that now? So when you move closer and closer and closer to the answer, that is iteration. Do you get that now? So let's do that now. Since it is sequence, we start with x naught. X naught, which is x sub 0. When you put this sub here, means n. When you put 0 here, you are going to be having 0 plus 1, which is what? 1. That means you are having x1 to equal the cube root of 3 minus this xn, which is going to be x naught now, is equal to what? 1. Are you getting this now? What does this mean now? This simply means the square root, the cube root of 3 minus 1. So if you press your calculator for 3 minus 1, that will give you 2, right? So when you take the cube root of 2, you should be having something like this. So I decided to write it fully like this because they asked us to take it to 2 decimal places. So I need to be seeing the entire pattern so that we know where to stop. Now, this value now is the value for x1. Am I making sense? So since x naught is equal to 1, I will put it into this to get x what? X1. For us to get x2, it's just n is now 1. So 1 plus 1 is what? 2. That means we are going to have the cube root of 3 minus answer. Am I making sense now? Okay. So when you press your calculator, that is, you put this value into this place, and you say 3 minus that value, then you take the cube root of it, your result should be, now that we have this, 1.20278956.4. We are going to continue like this until this answer to 2 decimal places start repeating itself. Am I making sense? So when that answer starts repeating itself, that is where we are going to stop. That means we've gotten our answer to 2 decimal places. I hope you get this. So put this value into x3 now. So we have the cube root of 3 minus answer, that is this answer, into this place. You can also use your calculator so that you can follow up. So to 2 decimal places, to 1 decimal places is repeating, right? So if it is to 1 decimal places, we might likely stop here. Am I making sense now? Because if we continue, it's this one that will start increasing. Am I making sense? This one will not increase. That means to 1 decimal place, our answer is going to be 1.2. But the question says to 2 decimal places. We need to get to x4. So for x4, we do the same thing. The cube root of 3 minus the answer that we get for x3. And that will give us what? X4. So if you compare this value and this, you get to see that this second one is not increasing again. To 3 decimal place now, it is this 2 that is going to increase. This one is not going to increase. So with the look of things now, we can safely see our result is 1.21. But don't let us conclude yet. Let's try one more. So x5 now. I believe you understand what I'm saying now. Because if you do another one now, this one cannot increase. Reason because this number is not up to 5. Am I making sense now? Before this number will get to 5, it's going to take a lot of iterations. And we're just looking for answers to be correct to 2 decimal places. So we're already approaching the answer already. So it is safe to stop here, but it's better. We'll check better so that you get what I'm saying. So this is 3 minus answer, which is this answer. So if you look at it now, you guys will see that to 2 decimal places, it's not increasing. It's just 1, 1. Can you see what I'm saying? It is the third digit that is increasing. So if the question says that to 3 decimal places, we cannot stop yet. But the question says to 2 decimal places, and with what we are seeing, this is just 3, it's going to increase to 4. So this one can still not increase. Am I making sense now? So we can conclude and say the value of x is equal to 1.21. You put in brackets to 2 decimal places, and you have successfully responded to that question. So this is the basic one that I'm very sure that you are familiar with, which is what your teacher will probably show you, the pattern your teacher will probably show you in class, because this explains the concept of iteration in a very simple manner, right? The examiner will not always test you with the easy one. So let's look at another pattern that is a bit different from what we have here. Can we? Good. Now, this is another pattern other than the one that we started with. If you look at this pattern of question that we have here, you can see that the cubic equation x cubed plus x squared minus 4x equal 3 has 3 solutions. The first solution lies between minus 3 and minus 2. The second solution lies between minus 1 and 0. And the third solution lies between 1 and 2. Now, if you look at this, we are asked to look for 3 values of x. Like I explained to you earlier, that whenever you have a cubic equation, you are looking for 3 answers. And if you are asked to just look for 1 real value, that means there's possibility that the remaining ones are imaginary numbers, which you are yet to be exposed to. Now, how do we answer this? This is quite simple as well. We do the same iteration. However, the difference between the iteration that we want to do here is that we have to make a proper guess within the value given to us. For the first one, if we want to look for the first value of x, we have been told that it lies between minus 3 and minus 2. What does that mean? That means that value of x, if you are going to make a guess of it, it cannot be minus 3. At the same time, it cannot be minus 2. It has to be greater than minus 3, but it must be less than minus 2. Do you get that now? That's the clue. And when we are looking for the second one that we are looking for is between minus 1 and 0. That means it must not be less than minus 1 and it must not be greater than or equal to 0. Likewise, it must not be equal to minus 1 as well. That's how we make our guess. The same thing goes to the third one, which lies between 1 and 2. That means the value must not be 1 and it must not be 2. So it has to be greater than 1 and less than 2. That is it. So that helps you to make a proper guess. Now, for you to understand how the pattern goes, I would like to draw a table like this. And this is going to be our guess value for x that we are looking for. And here is our evaluation part. That is where we are going to evaluate the table, the question given rather. Now, some cases in the exam, they might give you the table to complete if they want to give you hints. Am I making sense? But if they don't give you hints, to make your work neat and clear, you get a rough sheet of paper, then draw your table like this. So this is where we are going to make our conclusion to talk about it if it is too large or too small. So we don't want the one that is too large and we don't want the one that is too small. We want a value that is exactly the value we are looking for or closer to it. And how are we going to know? You know this equation, x cubed plus x squared minus 4x equal 3. So what we are going to do is that let's make our first guess to be minus 3. If we do that, then instead of x here, we'll put minus 3 there. That will be minus 3 cubed plus minus 3 squared minus 4 into minus 3 equal. So instead of us to write 3, we are going to write whatever result this gives us. If that result equal to 3, that simply means that this minus 3 is the value of x that we are looking for. If the result is closer to 3, very, very close to 3, that can be the result we are looking for. If it is less than 3 or greater than 3, that cannot be the result we are looking for. Do we get that now? Good. So if you look at this now, this should give us minus 6. So minus 6 is too small compared to what? To 3. The distance is far. Am I making sense now? So it cannot be the answer. This is too small. It's too small. Okay? So we go to the next one, which is what? Minus 2. Let's check that as well. Maybe it's going to be. We always start with what we have. That makes it easier for us to make a proper guess. So if you do this now, this should give us 4. So if this one gives us 4, press your calculator. Minus 3 cubed plus minus 2 squared, that is minus 8 plus 4 plus 12. That should give us 4. Okay? So if that should be the case now, if that should be the case, this is too large. This is too large. Are you getting this now? Good. So if this value is too large, because what we are looking for is 3, and since the value is too larger than 3, we cannot settle down for minus 2 as our answer. So we need to make another guess, and that should be, but if you look at it, it's getting closer to 3 already. Am I making sense? If that should be the case, let's guess minus 2.1. Minus 2.1. So you put it here, minus 2.1 squared, cube, plus minus 2.1 squared, minus 4 into minus 2.1. So what will this give us? We have 3.549. This is also too large. 3.549 is too large, so it cannot be our result. It can be. Okay, we'll go to the next guess. Let's guess minus 2.2. This should give us minus 2.2 cubed plus minus 2.2 squared minus 4 minus 2.2. What would this give us? This should give us 2.99, if I'm not mistaken. You can check your calculator for that. Then this is almost exactly, right? This is almost exactly like 3. So for us to conclude, let's go one step further. And that will mean that let's just go one step further. Instead of going to 2.3, let's just go to 2.25. Am I making sense now? So we'll get close to this and see what is likely going to happen. So if the value reduced from this one, because you can see if the value should reduce from this, because the values are now reducing as the value of x is also reducing. So if this value reduce, what will happen is that we are going to come back to this. We cannot continue further because it will just continue reducing further if we go on. So go back to this. Minus 2.25 cube plus minus 2.2 square minus 4 minus 2.2. This should give us 2.672. And I think this one is 2.992, not 6. So if you look at this now, you get to see that 2.672 is lesser than this, right? So this one is very, very close to 3. Then we can conclude that the value of x that we are looking for, the value of x is equal to 2.9, sorry, no. What gives us 2.99? That's minus 2.2. The value of x is 2.2 to 1 decimal place. I hope you get this now. That's the first solution. So we can now find the second solution. So let's write the first solution here. So x1 is minus 2.2. So you know how we do it now. We should be able to do it more simpler now because we already get the pattern. So, so for the second one, we are told that the second lies between minus 1 and 0. So let's start with minus 1 and see what we are going to have. We'll put minus 1 there, minus 1 cube, plus minus 1 square, minus 4 into minus 1 equal what? This is going to be minus 1, this is going to be 1, and this is going to be 4. So that means our result is 4. Do you get this now? Okay? Is 4 close to 3? Very close, but it's too large. It's larger than 3. So this is too large. Minus 1 cannot be the answer. So what about 0? We have 0 cube plus 0 square minus 4 into 0. And our result is just 0. This is too small. Am I making sense now? This is too small. It's too small. Okay? So we have to make a proper guess now. Since this 0 is too small and minus 1 is getting us closer to the answer, then we can make our guess to be, let's say, minus 0.9. What would that give us? Let's check. Minus 0.9 cube plus minus 0.9 square minus 4 into minus 0.9. That will give us what? 3.681. This is also too large. So we have 3.681. That is too large. So we try another one, 0.8, and let's see what we are going to have. Minus 0.8. So if you have this, minus 0.8 cube plus minus 0.8 square minus 4 into minus 0.8, and that's 3.715. This is also too large. Okay, let's go to the next one. Minus 0.7. That will be minus 0.7 cube plus minus 0.7 square minus 4 into minus 0.7, 2.947. So we have 0.7 to get us closer to the answer, which is 2.947. This is very close to 3. So let's try the next one after it, because since this one is very close to 3, we are not going to like to jump directly to minus 0.6. So let's just try minus 0.75. Minus 0.75. So if you do that here, minus 0.75 all cube plus minus 0.75 square minus 4 into minus 0.75. So what will this give us? 3.141. So if you look at this now, 3.141 is greater than this. Am I making sense? And I've told you, you cannot approximate the number that is greater than the number you are looking for. However, you can approximate the number that is smaller compared to what? The number you are looking for. So that means we're going to settle down for 2.947 instead of 3.141. So what number give us that 2.947? That is 0.7. That means x2, the second solution, is minus 0.7. That's the second solution. Now we can find the third solution, and we are told that the third solution lies between 1 and 2. So we start with 1, and we have 1 cube plus 1 square minus 4 into 1 equal what? So this is going to give us 2, and this is minus 2. Minus 2 compared to 3, that is too small. It's too small. Are you getting it now? It's too small compared to what we are looking for. So 1 cannot be the answer. What about 2? So 2 cube plus 2 square minus 4 into 2. This is going to give us 8 plus 4. That gives us 12, right? Then minus 8, that will be 4. This is too large. It's too large. So it cannot be the answer because we are looking for answer that will give us 3. Okay? So what again can we do? Let's now make a guess of number now. So if this is 2 and it's giving us 4, then we need to look for a number that is smaller than 2 but closer to 2. Do you get that? So we try 1.9. That means we have 1.9 square, 1.9 cube plus 1.9 square minus 4 into 1.9. We have 2.869. So this is getting us closer to 3, right? So let's try another one. Since this one is getting us closer to 3, instead of us to jump to 1.8, we just jump to 1.95. 1.95 square plus this is cube, 1.95 square minus 4 into 1.95. So if you press your calculator, 3.417. Good. So this is what we're going to have, 3.417. By pressing our calculator, we should have this. So this one is larger and this one is smaller. So we settle down for this. That means the value of x that will give us a number closer or equal to 3 is 1.9. So that means the third value that we are looking for, x3, is 1.9. You can see now how we get the 3 solutions that we are looking for. So if you are given a table, all you just need to do is to copy the table, fill it, and under the table, just like this, you say the value of x is equal to, what value give us this? 1.9 in bracket 1 decimal place to 1 decimal place. Am I making sense now? So that's pretty much it. This is another pattern still under iteration method. The equation x cubed minus x squared minus 4x minus 9 equals 0 has one solution. That is, it has just a single real solution. The remaining 2 solutions are imaginary. Okay? Use iteration machine below to find the solution to 2 decimal place. So we're looking for that one solution to 2 decimal place. Use the starting value x naught equal 3. So we are told that we should start with x naught equal 3. So you can have this instruction under it as a guide to give you hints on how to go with the question. So I start with x naught. Find the value of xn plus 1 by using the formula, which is this. This is the iteration machine that they are talking about. So if you keep on doing that, if xn equal xn plus 1 rounded to 2 decimal places, that is, once the previous value and the current value are equal to 2 decimal places, if you round them up to 2 decimal places and they are equal, stop there. That's your answer. But if they are not, you have to continue repeating the same steps. This is quite similar to the first one that we did. Do you get where I'm coming from? But because of the change in language and the change in structure of the question, it's likely for you to see it as something new. And that's why mathematics is all about pattern. You are brilliant, you know it. However, if you are not conversant with the patterns, that might be something that makes it complex or look confusing for you. Just by the change of language and the way they structure the questions, it might feel strange. It's normal. So we do this as we did the first one, right? So let's get started. So we're starting with x not equal to 3. For better space, let me clean this. Okay, so let's get started now. If I put this 0 here, that will make this to be x1. x1 will therefore equal to the cube root of, this is x squared, so I'll put the 3 here, plus 4 into 3, then plus 9. So I'll press my calculator to evaluate this. I think this should give us 30. Then I'll find the cube root of 30. Now that I've gotten this answer is what I'm now going to use in place of x. Are you getting this now? That means I'll write this x2 is now going to be the cube root of answer square plus 4 into answer, then plus 9. Are you getting this now? The square root cover everything. So this answer is what we have inside here. It's too long for us to write it. It's not making sense. That's why I put answer inside the bracket. I hope you get that. So if you do, this is equal to, so we can now go to the third one. 3.14420953086. This one does not equal to this one, right? Even if we round up to 2 decimal places, that means we need to go to the third one now. Now, the answer that we have here now is this, not this one now. This answer that we got here is what we are putting here now. I hope you understand the pattern now. This is going to, if you round this up to 2 decimal places now, it's not the same as this. Because if I round this to 2 decimal places, that will be 3.14. And this one is going to be 3.16. So I still need to continue to x4. So x4 is going to be the cube root of answer square plus 4 into answer plus 9. So which answer are we talking about? This one, not this one. This one now is what you're going to put here. And your result is going to be, so if I round this one up to 2 decimal places, is it going to be the same thing as this? Yes, it will. Because this one is going to become 6. Okay. But right now, I can't stop here. The reason why I cannot stop here is because we want this to be very much closer. We're already getting close to our answer. I can actually stop here because if you look at this now, if I continue now, that means this 6 cannot increase. Am I making sense now? This 6 cannot increase. It's only this one that is going to be increasing. So it's safe for me to say my x is going to be 3.16. But don't let us conclude yet. Let us move one step further so that they look very much similar. Is that taken? Good. x5. We'll do the same thing. The cube root of answer square plus 4 into answer plus 9 equal. So this answer now is what we are putting here. So if you look at it now, if you round it up to 2 decimal places, it's the same thing as this. If you continue to move further, it's only this one that is going to increase to probably 3. This one is not going to increase. So since this one, x5 and x4, if you approximate them, that is you round them up to 2 decimal places, they are the same thing, then we can stop here and we can say the value of x, which is the solution that we are looking for, is 3.16 to 2 decimal places. I hope you get this now. So these are various patterns that you can find question under this. So sometimes it's not necessarily that it's going to be a cubic equation like this. It can be rational equation. Are you getting this? And I'll give you that as assignment so you can play with it. Now that you have been exposed to different patterns under the iterative method of solving mathematical equations, I'm going to give you another pattern that is different from the ones that we look at in the class so that you can practice it and you can send it to me to review it, and you're going to get a personalized feedback. Send this to my Gmail at mathphytutors@gmail.com, and I'm going to respond to you personally. Now, if you want to be better at mathematics, you need to expose yourself to different patterns, because your teacher will expose you to few patterns in the class as example to understand the topic. However, they'll give you a classwork that is a bit above the example. That is another pattern. And when they give you assignments, it's usually totally different from what your classwork looks like and what your examples in class looks like, because they want you to get to see more of the pattern, and that's why you get confused with your assignments. However, the more you can focus on looking for patterns in mathematics, the better you can become. So try this and make sure you send it to me. I would like you to send me this, and I would like to give you a personalized feedback. Let's look at that. Use the iteration machine below to find the three solutions to the equation 2x cubed minus 5x plus 1 equals 0 to three decimal places. Use the starting values x naught equals 0, x naught equal minus 2, x naught equal 2. And here is the machine. Xn plus 1 equal 4x cubed sub n minus 1 divided by 6x squared sub n minus 5. And let's see what you're going to come up with. See you on the next one.